In the previous video, we talked about mapping common constructs in an ER diagram onto relational schemas. There are some edge cases we need to discuss though, so let's go over those. Let's start out with an easy one, derived attributes. Since derived attributes aren't actually represented in the database, we don't need to account for them in the database at all. If that's all you remember about derived attributes, that's enough. Ultimately, derived attributes make for a tidy description of what the difference is between an ER diagram and a relational schema. ER diagrams are mapping requirements, and a derived attribute is one of those. In this case, for example, it's important to know what a student's age is for whatever reason. But when we put this into a database, the need for that information doesn't change. But we also wouldn't need to have a database column to represent it. Accordingly, we omit it. Multi-valued attributes are a bit more complicated. Here we have an example of a class which may have multiple books. Since we can't put multiple values into one cell, the simplest way to handle this is to create a new table and have a foreign key linking each book back to the class ID. Now, since we're creating a table, we need to define a primary key. In this case, we're going to have two columns in the table, class ID, which is the foreign key, and books, which is the attribute itself. The whole reason we're making a separate table is because we expect that in at least some cases, a class will have several books, and as such, we expect class ID to repeat. So we can't use class ID on its own as a primary key. But what about books? Remember that we're going to have books for every class in this table, and it's a reasonable assumption that two classes might have the same book in at least some normal cases. So we can't use books as a primary key on its own either. So that leaves only one option, using everything as a primary key. Remember that each row in the database has to be unique in its entirety, so if we're following these rules, using all columns as a primary key will always work. We generally want to use the minimum number of columns possible for the primary key, but in this case, this is the only choice we have. So we go ahead and mark both columns as a primary key. In general, this is best practice for handling multi-valued attributes. Just use all the columns in the resulting table as a primary key. Unary relationships are handled exactly the same way as binary relationships, but the foreign key loops around and points to the primary key in its own table. In ERD+, this feature is called a recursive key. One thing we have to keep in mind is we can't have the same name for two columns in the same table. When we're pointing to a key in another table, as we have been up until now, we haven't needed to worry about this. But when we're pointing to the same table as we are with a customer here, we have to give it a different name. In this case, I chose refers_customer ID to include the name of the relationship. M-to-N unary relationships are handled in the same way as they would be in the binary context, but the key difference is that the relationship table has two foreign keys which point to the same primary key. See page 83 in the Yukich book for an illustration of this. Finally, let's talk about weak entities. Remember that when we have a table in a database, we need to have a primary key, and that primary key needs to be unique. Also remember that a weak entity is defined as not being identifiable outside of the context of an identifying relationship. In this case, what this means is that we need to include the identifying relationship's foreign key in the weak entity's primary key. Since the primary key is made up of more than one column, any foreign key linking back to the table is also going to be made up of more than one column. You can see how this is represented in the relational schema here. The users table links back to the computer weak entity and uses both the classroom number, which is a foreign key in computer, as well as computer number, which is a partially unique attribute in computer. Other than that, weak entities effectively work exactly the same way as all other entities.